classroom is one where there's good acoustics so that your voice can be heard clearly with little background noise. According to the American National Standards Institute, the recommended noise level for an unoccupied classroom should be at a level around 35 dBA. When children are inside the classroom, this could add another 10 to 20 dB of noise into the room. A relaxed teacher's voice is typically around 60 dB. So let's put this into perspective. If you have a classroom with students in the room producing around 10 decibels of noise, 45 decibels altogether, and a teacher speaks at 60 decibels, there should be a positive SNR of 15 dB. Additionally, the reverberation time, or the time that it takes for a sound to reflect back to the source and dissipate, should be between 0.4 seconds and 0.6 seconds. The greater the time it takes for a sound to dissipate, the more echo you hear. Now that you know the levels of an optimal classroom, do you think the classroom that you're currently working in are meeting these levels of expectation? You're probably right. Noise, reverberation time, and estimated speech intelligibility in most classrooms in the United States are unacceptable. The average levels found in a study showed that the noise level in most rooms is around 49 decibels, and a teacher's voice were around 59.5 decibels, creating an average signal to noise to a positive 11 dB. This doesn't sound terrible when a goal is 15 dB, but let's break it down based on age. Since we know that children's auditory systems are growing at different rates, let's see what SNR levels are needed at each age. For students to understand 95% of what you are saying, in first grade, you will need an SNR of positive 15.5 dB. In third grade, you will need a positive 12.5. And in sixth grade, you will need a positive 8.5 dB. So if you are teaching young children, more than likely, your students are missing content on your lessons solely on the fact that there's background noise in your room. Nonetheless, the other distractors in the room. Unlike background noise, which is relatively constant in the room, your voice, or the signal, varies on where you are in the room and where the SNR is being measured from. A student in the front of the room will have a better signal-to-noise ratio because they're closer and having a better access to the signal. A student in the back of the room may have a poor SNR signal because they are farther from the signal, but yet is still receiving the same amount of noise present in the room. So students who are farther away receive a lower signal because sound decreases with distance. Every time that you double the distance from the listener, a 6 dB decrease will occur. The chart below explains the typical classroom layout and how the distance will affect the signal that your students hear. Let's say you as a teacher at 3 feet in your room are heard at 60 decibels. At 6 feet in your room, you'll be heard at 54 decibels. At 12 feet in your room, you'll be heard at 48, and so on. Since the background noise is staying relatively the same, this decline in the teacher's voice means that the signal-to-noise ratio will be declining over the distance of the room. To put this in perspective, at 3 feet, you will have an SNR of positive 15. At 6 feet, the SNR will decrease to 9 decibels. At 12 feet, it will decrease to 3 decibels. 24 feet, you will have a negative 3 decibels. After viewing this video, reference the signal-to-listener distance chart below to see how it can affect your students' listening skills, while also remembering the recommended levels that were mentioned previously. Now that you have learned the amount of noise present in your room is unacceptable for your students to learn in, let's go to the room treatment section to learn how to modify your classroom to absorb these unwanted sounds.